So welcome everybody to this latest video on 162 Maths, and in this video we'll be looking at algebraic fractions with a focus on simplifying single fractions. Now this topic is a higher GCSE topic and also goes into A level, so if you are not working at that level then this video might not be for you, but still worth knowing because it's all maths is good maths. Now when you have an algebraic fraction where all the terms in both the numerator and the denominator have a common factor, then we can simplify without factorising. Now also bear in mind that not all algebraic fractions can be simplified, and I'll just go through some of the basics of the things that you should be seeing in your head when looking at one of these questions. So first of all, let's just get a decent colour pen, let's go through the screen. So with question 1 we can see that the first term on our numerator is 12x and we've got a denominator is 18. So what have they both, numerator and denominator, both got in common? Well, they've both got numbers. Can we simplify both the numbers? Yes we can. What number goes into both 12 and 18? That'd be 6. So what I'm going to do is divide both numbers by 6, in which I get 2, and that then becomes a 3. And then what I'm left with is 2x over 3. With question 2, again looking, I've got numbers x's and y's on both the top and the bottom. So looking at the numbers first, now I can't really simplify 11 and 21 because there isn't a number apart from 1 that goes into both those two numbers. Looking at x, I've got 1x at the top and I've got x cubed at the bottom, so I can take that x and that means I've only got 2 left at the bottom, and I've got 2 y's at the top and 1 at the bottom, so I can take the 1 from the bottom, take 1 from the top, and then all I need to then do is write down what is left. So on the top I've got 11y and at the bottom I've got 21x squared, and there is my simplified fraction. We're looking at question 3. Now with question 3 each term has got numbers, but not all of them have got letters. In fact, and also not all of them have got x's. So looking at the numbers, I've got 12, 23, 8 and 3. Now in order for me to cancel any of this down, all of those need to have a common factor, in which there is no common factor apart from 1, and we don't include 1 as a common factor. So I cannot simplify any of the numbers. Now I can't also cancel any of the letters because although 3 of the 4 terms have got x's, there is that one that hasn't got an x or a y, so I can't actually cancel that down. So for this one, it cannot be simplified. Now, I wouldn't write CBS, only I know what that means, but like I said, what I'd write in words is cannot be simplified, obviously CBA in terms of writing that down. So in terms of question 4 or example 4, we've got 7x minus 12y, 8x minus y. So again, there is no common number that goes in. Now obviously if there is no number in front of the y, but I can imagine there's a 1, and again can't cancel in terms of regards to 1. Also, not all 4 terms have got the same letters, so again that one is a CBS. Looking at question 5 now, with question 5 I can see that all the 4 terms have got numbers, so I can cancel. Let's have a look if I can cancel those, and yes, I can take 2, but I can divide each of those numbers by 2. That then becomes a 4, and that becomes a 7. Now also each term has got x, at least one x anyway, so I can take away the smallest amount of x, which just happens to be 1. So I'm going to do is cancel 1x from each of those terms, and obviously only these two on the right hand side have got y's, so again I can't cancel y's, and also this bottom left hand corner term's got a z, so there's nothing really I can do with that. So all I then need to do is understand my crossing outs and simplifying and just write down what I've got left. So I've got 1x minus 5y over, and it's going to be 4z plus 7y squared, and there is my final answer. Now looking at question 6, I've got brackets, so this has been already factorised. So what you can treat this as there are 2 terms, because we haven't, a term is things that are being added or subtracted, and so at the top I've only got 1 term because I haven't got anything being added or subtracted. Even though I can see minuses and pluses, the fact that I've got 2 brackets and there's no symbol in between them basically means that these 2 things are being multiplied. So I can treat this in the same way as, let's say, that. Okay, where the 3 is being multiplied by the x, the 5 is being multiplied by the x, but again this is similar fashion. So what you want to do here is that basically I can cancel out common brackets. So if there is a common bracket on the top and the bottom, I can cancel it down. So I can cancel this x plus 5 with this x plus 5, leaving me with just x minus 6 over 2x minus 3. Now, when simplifying an algebraic fraction, you need to treat the numerator and denominator as separate expressions that you need to try and factorize. Now, to do this effectively, you will need to fully understand how to and when to factorize into single and double brackets. And this is both covered in previous videos, in which I will include links literally everywhere in this video. Now, let's just have a quick refresh on factorizing simple expressions. So here I've got 3x minus 9. So again, I want to think to myself, what's common about these two terms? Well, they've both got numbers. What number goes into both those two numbers is 3. So I've got 3, but I want 3x, we need another x. And I've got 3 and I want 9, so what do I need to multiply 3 to get 9? That's going to be 3. Looking at question 2, well, both the terms have got numbers. And so what's the biggest? Is there a common factor between 25 and 5? Well, yes, there's 5. And what letter have they both got? X. And is that the lowest power? Yes. So I've got 5x, but I want 5xy, so I need to multiply it by a y. And I've got 5, but I want 25, so I need another 5. And I've got 1x, and I need 2 x's, so I need another x. For question 3, this involves double brackets. So here I've got to think to myself, what number multiplies together give me 15, added together gives me positive 2. And my two numbers are going to be 5 and 3, in which my 5 is going to be positive and the 3 is going to be negative. And then finally for question 4, here I've got difference of two squares. So it's going to be x 4. So what do I have to square to get x squared x? What do I have to square to get 16? It's 4. One's a plus, one is a minus. Now just a little bonus, if you did have something that had, like, let's say x plus 3, that can't be factorized. So what we just do is just put a bracket around that. And if you want to write a 1 there, then that's absolutely fine. So if you do have an expression that you can't factorize, you could write it like this, particularly moving forward. I wouldn't write CBS in this stage because, like I said, it's not going to be relevant. But I would certainly, if you have got an expression that cannot be simplified, then just put the brackets around it and stick a 1 in front of it if need be, but the 1 is going to be optional. So let's have a look at these examples. So with question 1, now there's several ways in which how you can approach these questions. Now here we've got 3 terms in this question. I've got my numerator, got my denominator, and each number on each term, I should say, has got a number. Now looking at, is there a common factor between the numbers? Yes, I can divide both numbers by 2. So that then becomes a 4, that becomes a 2, and that becomes a 1, giving me a final answer, or an answer of 4x plus 2 over 1. Now when we divide by 1, it's just basically itself, so I can write this as 4x plus 2. Now one thing that you want to try and get to notice is, well, can I factorize this? Now to be fair, that is your final answer, that is that fraction simplified. However, if we then wanted to factorize this, to maybe potentially factorize this further, or simplify this further I should say, then this would become 2 lots of 2x plus 1. So any of these two answers would be sufficient for this particular question. However, for more high level questions, you may want to look at giving an answer like this, just in case it can be simplified further. So let's have a look at question 2. So question 2, again looking at this, I've got 3 terms, I've got numbers, so let's have a look at finding a common factor between 2, 6 and 4, which is going to be 2. So if I divide both numbers by 2, then what I end up with is 1y plus 3 over 2. And again, 1y is just y, so I'm just going to write that's y plus 3 over 2. Now, can I simplify this any further? No, because obviously I've got a single term and just one of them, and I've got 3 and 2, which don't cancel down, so that would be my final answer. Looking at question 3, so again I've got letters and numbers. So looking at the numbers, again, is there a common factor between the 3 terms where they've all got numbers? Well, yes, there's 7, so if I can cancel 7, divide all the numbers by 7, in which then what I'm left with is 1x over 2x minus 3. Now I can't cancel the x because there's no x in that third term of 21 or 3. So then this then just becomes x over 2x minus 3. And I can't factorize the bottom, so I'm just going to leave it as it is, and there we go. Now for question 4, again here I've got numbers. So each of the 3 terms have got numbers. So think to myself, what goes into both all those 3 numbers? That's going to be 3. So divide both numbers by 3. Then what I get is that. And I also notice that every single term has got a y, so I can cancel a y, and I then get that. Then looking at what's left, I've got 3y over 1 plus 9y. And again, I can't cancel the 3's because the 1 is blocking it, and I can't cancel the y's because the 1 hasn't got a y. So that there would be my final answer. And moving on to question 5, which I'm just going to do over here. I've got x minus 4 over 5x minus 20. Now again, not all the terms have got numbers and not all the terms have got letters, so I can't cancel it down straight away in terms of that sense. So what I'm going to do is I'm going to treat the numerator and the denominator as separate expressions. Now I can't simplify the numerator because that's just x minus 4, but I can factorize that bottom. If I just write x minus 4 and put that in brackets, I can factorize this bottom, so I can take a 5 out and then go through the motions, and I've got x minus 4. Now lo and behold, I now have got an x minus 4 in both the top and the bottom, which I can cancel both of those two things down. And if I wrote down a 1 to begin with, then all I'm left with is 1/5. Then moving on to question 6, I'm going to keep this yellow pen because it's quite nice and bright. I've got 6y minus 30y squared over 24y squared. Now again, I don't need to factorize, although I may need to later, but each of the terms have got numbers and all the numbers are multiples of 6. So I'm going to divide both numbers by all the numbers by 6. So that becomes a 1, that becomes a 5, and that becomes a 4. Now each of them have got y, so I'm going to cancel a y from every single term. So then look at what's left. I've got 1 minus 5y over 4y. And again, I can't simplify that any further, and so there we go. Now ideally what I could have done for question 6, an alternate method, is I could have factorized both the top and the bottom. So in terms of treating this as a single expression, I can treat this as 6y, because both of them have got 6y, and I've got 1 minus 5y over, and again looking at this I can take out well, I can't do anything much in terms of that, so I've got 24y squared, and then from this what I can then do is cancel this 6 with this 24, so that becomes a 1 and that becomes a 4, and I can cancel that y with that y, leaving me with the exact same answer. Now if you didn't quite understand that second method, then do not worry, as long as the first one made sense, or at least one of them made sense, then we're looking good. So looking at some more examples, let's have a look at question 7. Now question 7, you might think to yourself, well, that doesn't like we can simplify that because not every single term has got a number, not every single term has got a letter, and also I can't really simplify the top and I can't simplify or factorize the bottom, so there's not much else I can do with this one. Now this one is a little bit sneaky because there is something that we can actually do. Now one thing I could do is if I was to factorize the numerator with respect to minus 1, then that would become, I'd end up with minus 1, and minus 1 times what gives me x, well that be minus x, and minus 1 times what gives me minus 4, well that be positive 4. Now if I then flip these two things around, then what I end up with is minus 1 end up with 4 minus x. Now if I then bring the denominator back in, you can see that I end up with a 4 minus x at the bottom that was already there. And now what I can then do is I can cancel these two brackets, leaving me with a final answer of minus 1, which again you may have thought couldn't happen, but actually when you think about it and things you can manipulate, well hopefully now if you get a question like this you'll understand how to get it. Looking at question 8, now again I can, well looking at the all four terms have all four terms have got numbers, so I think to myself, well okay, what is there a number that goes into each of those numbers? Yes, I can divide both numbers by 3, so let's do that first. I can divide 21 by 3 gives me 7, 3 divided by 3 gives me 1, 42 divided by 3 gives me, and that's going to give me 14, and 6 divided by 3 gives me 2. So what I'm left with is I'm left with 7 minus x over 14x minus 2x squared. Now I can simplify, if I then put brackets around this and this, I can't simplify, I can't factorize the top, so that stays as it is, but I can factorize the denominator, because looking at this I've got 14 and 2, so I can divide both numbers by 2, so I can take 2 out, and both terms have got x, so I can take that out. And then what do I need to multiply 2x to get 14x? That's going to be 7, and what do I have to multiply 2x to get minus 2x squared? Well, that's going to be minus x. And lo and behold, by sticking a 1 there, I can cancel those two brackets, which then leaves me with 1 over 2x. Now you will find that these questions are going to be a higher GCSE level or even low level, sort of A level. So if you think, well, do you know what, I never would have got these questions, well, hopefully by me working through these questions and talking you through what to look out for, hopefully it will make a little bit of sense. Now, in terms of question 9, again, there's nothing we can do in terms of cancelling terms outright, because although I've got 5 terms, not all of them have got numbers, not all of them have got x's, so there's nothing there I can do. So what I need to do is treat the numerator and the denominator as 2 separate expressions. So here, factorising the top, well, there's no factor that goes in, so I'm just going to put one lot of x plus 2 over. Now this is a quadratic. So here what I need to do is think to myself, okay, what two numbers, factorise is quadratic, so what two numbers multiply to give me 10, added together give me 7, well that's going to be x plus 5 and x plus 2. Now then what I've got is I've got an x plus 2 in brackets on both the top and the bottom, so I can cancel that down, so all I'm left with is 1 over x plus 5, and if you want to put that in brackets that's fine, but again it's not necessary, so I can just leave it as that. Looking at question 10, now running about a bit of space, so let me just put that here. So with question 10, again, I can't simplify both the top and the bottom, so I'm going to just treat the numerator and denominator as 2 separate expressions. Now the top is a quadratic, so you think of, okay, what two numbers multiplied to give me 36, multiplied or added or subtracted to give me minus 13, well that's going to be 9 and 4. I've got 9 and I've got 4. And 9 is going to be, well, both going to be minus, and over, and I've got one lot of x minus 4. So here again I can cancel my x minus 4s out, leaving me with just x minus 9 over 1, which is just x minus 9. There we go. That's question 10. So then if we just have a look at question 11, so let me just get rid of all of this. So looking at question 11, so question 11 I've got, let's say, factorising the 2. So again, I can't just simply cancel things off because not everything's got a number, not everything's got a letter. So looking at the top, I've got to think of 2 numbers that multiply together give me 20, added together give me 8, and that's going to be 10 and 2. And looking at this, I've got that the 10 is going to be minus, the 2 is going to be positive, and then factorising 9 x plus 18, well I can take a 2 out, in which 9 times, no I can't, I can take a 9 out rather, let's just change that for 9. 9 times what gives me 9x, well that'll be x, and 9 times what gives me 18, that's going to be a 2. And again you can see I've got a common bracket, which you'll generally tend to have, so I've got x minus 10 over 9, and there's my final answer. And then for question 12, again factorising the top, I get 5, so I've got x plus 8. At the bottom, I've got to think of 2 numbers. Now, you'd expect one of the brackets to be 8 or x plus 8. So what times 8 gives me minus 16? That's going to be minus 2. And there we go. And then obviously then I just need to cancel out those 2 common brackets and then write down what's left. And what's left is 5 over x minus 2. Now looking at these extension questions, now here we need to take our factorising quadratics to another level. So for this it's complex factorising, and again I'll include a link to a video on how we actually do this, but factorising number 13, at the top we get 3x plus 1 and 2x minus 1, and at the bottom we're going to get 5x plus 1 and 3x plus 1. And again, as you can see, we've got a common bracket, which then just leaves me with 2x minus 1 over 5x plus 1. Again, looking at this, I can't simplify it any further because not all the terms have got an x, and although all the terms have got numbers, again, they haven't got a common factor, so that there is my final answer. With question 14, now with question 14 it's a little bit tricky on this one. So here, this is involving a difference of 2 squares. So the first numerator, I can write, so x squared minus y squared. I don't know what to put that in brackets. Let me just get rid of that. So here we've got x squared minus y squared is actually x, y, and a y. One's a plus, one's a minus. Now x plus y all squared is actually double brackets, which is x plus y, x plus y. And again, there's always one student in my class that used to think that x squared plus y squared is x squared plus y squared, which it isn't, because obviously the square represents double brackets, so don't do that. So expanding these out, what we get then is I can cancel, both the brackets have got, both the numerator and the denominator got an x plus y, so I can cancel that out. So what's left is x minus y over x plus y, and there is my final answer. And then finally for question 15, again looking at both the top and the bottom, not everything has got a y, not everything has got an x, and although all of them have got a number, there isn't a common factor. Although 2 is very tempting, but we can't divide the 9 by 2, so that's not going to come into question. So looking at question 15, the numerator, what I've got is I've got 4y squared minus 9y squared, which again is a dots question. So it's going to be, what do I have to square to get 4y squared? Well, that's going to be 2y. And what do you have to square to get 9x squared? Well, that'll be 3x. And one's a plus, one's a minus. And then looking at the denominator, now this isn't a dots because 6 is not a square number, nor I've got an x cubed and a single y. So what I need to do here is just take out anything that's common between the two. Well, here I've got a 2 that's common between the numbers, and both of them have got x, and it's the lowest power is square, so I'm going to take that out. So here to get I've got 2x squared, but I want 4x squared y, so I need to multiply that by, I need another 2, and I need a y. And then move on to the next one. I've got 2, but I want 6, so I need a 3. And I've got x squared, but I want x cubed, so I need another x. Now, from this, what we can then do is see if anything simplifies. And yes, we can see that our latter brackets are both the same, so that cancels out. So what I'm left with is 2y minus 3x over 2x squared, and there is our final answer. Now, in terms of these last 3 example questions, they are extension, and you will be classing this as, let's say, level 9 or high GCSE, and also going into A level in AS level algebraic fractions and simplifying. Now, I will put some practice questions in the description below along with their answers for you to practice everything that you've learned in this video.